In today's lesson, we are again looking at trigonometric equations, but this time they contain fractions. We are going to solve for the general solution in the following example. We are given cosine 3 theta plus sine 3 theta times the tangent theta is equal to minus 1 over the square root 2 cosine theta. Now, before we start solving for this missing angle, well, we want to identify what type of equation this is so that we can plan what type of action we're going to take. So, the first thing that jumps to my mind is that here we have 3 of the functions. So, not just 2, we've got all 3. So, the first thing I want to do is change this tangent theta to a sine and a cosine function with the quotient identity. The second thing I can see is that here we have a fraction where one of our functions is in the denominator. So we're going to follow the same steps as we do in algebraic fractions. We're going to turn all our terms into fractions. Now, how do I turn a cosine 3 theta into a fraction? Well, we put it over 1. But we're not going to take this term and put it over 1. Why not? Because this tangent theta will already help us to do that when we change it with the quotient identity. And then this one is already a fraction. Now let's see what we have. We've got cosine 3 theta over 1 plus sine 3 theta. Then we use the quotient identity and we have sine theta over cosine theta equals, and this side is already a fraction. Now all our terms are fractions and we're going to make use of the lowest common divider. So we look at the denominators to find the LCD and we start with our constants. So 1 and square root 2, the LCD is square root 2. Then we go from left to right. Here's a cosine theta, so we include it in the LCD. Here's another cosine theta. Because it's already here, we don't include it again. So this is our LCD. Now, why do we have this? Because again, we want to get rid of these fractions. So how do we do that? We take the square root 2 cosine theta and we divide it with the denominator and we multiply the answer with our numerator. So let's do it. Square root 2 cosine theta divided by 1 is square root 2 cosine theta. And square root 2 cosine theta times cosine 3 theta gives us square root 2 cosine theta cosine 3 theta. We write the plus and we do it for the next term as well. Square root 2 cosine theta divided by cosine theta is square root 2, and square root 2 times sine 3 theta sine theta gives us square root 2 sine 3 theta sine theta equals, and we do it for the right side as well, so don't forget about the right side. We've got square root 2 cosine theta divided by square root 2 cosine theta, which is a 1, and 1 times minus 1 is a minus 1. And there we go, we got rid of the fractions. Now we want to change this left side into one term. Well, I can factorize by taking out a square root 2 as a common factor. And we have square root 2 in brackets cosine theta cosine 3 theta plus sine 3 theta sine theta is equal to minus 1. Then we take this coefficient in front of the bracket and we can divide with it on the right side. And now we have cosine theta cosine 3 theta plus sine 3 theta sine theta equals minus 1 over square root 2. There we go. So now here is our ratio, and our next challenge is to make this left side into one term. Well, we already tried to factorize it earlier and we couldn't, and we still can't. So now what can we do to change this into a one term? Well, if you look very closely, this represents a cosine compound angle. If we take this cosine 3 theta to the front, it looks like this. Cosine 3 theta cosine theta plus sine 3 theta sine theta. And this is a cosine compound angle. So what do? We write cosine. Because this is a plus, well, this compound angle will have a minus. So we will write 3 theta minus theta. And there we go. So now we also know that 3 theta minus theta gives us 2 theta. So we have cosine 2 theta is equal to minus 1 over the square root 2. And And there we go. Now we try and solve for this angle. Not theta yet, just the angle. So we take this cosine to the other side as its inverse, and we have 2 theta equals cosine to the power of -1. And don't forget, this ratio is negative, but when we write it in this bracket, we write it as a positive. We do this calculation on our calculator, and 2 theta is equal to the reference angle of 45 degrees, and I underline it. Now, something very important, do not solve for theta here. We only do it once we find the quadrants in which we need to work. So this is our reference angle, and then we go to where we have the cosine of its angle equal to the ratio. It's a negative ratio, so we're going to work in quadrant 2 and in quadrant 3. So we take 180 minus the reference angle. So we're going to write 2 theta is equal to 180 degrees minus 45 degrees, which is the reference angle, plus 360 degrees times k. Then we do this front part, and we have 2 theta is equal to 135 degrees plus 360 degrees times k. And now we divide with 2 to get theta. So theta is equal to 67,5 degrees plus 180 degrees times k. We also have to take this part and divide it also with 2. Now we're working in quadrant 3. So we do the same. It's going to be 180 degrees plus the reference angle, and we have 2 theta equals 180 degrees plus 45 degrees plus 360 degrees times k. Then we do this front part. We end up with 2 theta is equal to 225 degrees plus 360 degrees times k. We divide both by 2, and theta is equal to 112,5 degrees plus 180 degrees times k. And there is our 2 answers. See you again next time. Bye.